Hi, Ted Brooks with Alpha Maglogics. I want to talk to you more about safe lifting practices. In this one, we're going to talk about direction of force. You've probably all seen somebody with two magnets at the end of two chains. They actually have a magnet being pulled in this direction, another one being pulled in this direction. That is terrible for magnets. It may be great for those little J-hooks and chains, but it's not the way to use magnets. Magnets should always be used in what's called a pure tensile or straight 90-degree breakaway direction. That's what all these numbers on the side of the magnet are for. They're for 90-degree lift. So I'll show you, with the magnet turned off at the moment, a little bit about what these directions mean. In a pure vertical lift, it's actually got quite a bit of force. If I try and pry it sideways, it's incredibly easy to pry off. So if I was using a chain and it was at an angle like this, I could depend on having a lot less holding force available. If I do need to be at an angle for whatever reason, say I'm going to what's called shear force lifting, I always want to be in this direction because I've got significantly better holding force. As I turn it on, it would become even much greater, apparently, as you're using the magnet, how this types of direction of force help you. So you always want to do straight up and down. You never want to try to pry it at 90 degrees relative to the magnet. And if you are going to do shear lifting, it should always be in the same direction that the magnet is. Let's go ahead and do a shear force lift and talk a little bit about shear force. Shear force, for the people who are experts in engineering, I'm not one of them, is dependent on the coefficient of friction. Let's face it, you can put on a great pair of boots, you can do incredible things in asphalt and concrete with those boots on, but you get just a tiny little bit of ice and you're falling on your butt. That's coefficient of friction working against you. The same thing is true with magnets. If you've got this magnet on a bunch of debris, on a bunch of fine shavings, they're going to act like tiny ball bearings. All the holding force on the best magnet in the world, which is what we're offering you, won't mean a hill of beans if you're on something that's just going to act like ball bearings underneath it. So if I'm going to do shear force lifting, I'm going to be dependent on the coefficient of friction. In this case, we're up to about 33% of our breakaway is what we should expect in the normal conditions in shear pulling. So if this little guy is about 500 pounds of safe working load in vertical breakaway, he's going to be about 167 pounds in shear in your normal conditions. This particular piece weighs about 134 pounds, so I should be good with a 3-to-1 safety factor as long as I've wiped the bottom of the magnet off and I've wiped off the target surface, something you should do before every lift with every magnet. So we're going to go ahead and put the magnet in place towards the top, and we're going to lift this up into a vertical position and set it on the ground. Turn it on towards the top of the piece of steel. Don't ever forget, I'm not lifting that piece of steel up perfectly vertical when it does get lifted. The center of gravity is going to dictate it's going to be cocked at an angle. Just make sure you understand what to expect as you're doing the lift. I'll grab a hand lifter, make sure I've got good control over this piece as it's being lifted. Let's go ahead and hook it up to our crane. And of course it's going to try and swing until I get that crane directly overhead. There we go. I'm going to try and control the load with my hand. If the load gets out of control, get your body away first. In a test lift situation, I'm pretty comfortable. I've got enough holding force. We're bringing this off the edge of the table. At this point, it's completely suspended in air. As you can tell, it's not 90 degrees because the center of gravity simply isn't there. If I was going to be moving this around the shop, I'd want to once again just do a test to make sure I know what I'm doing. One of these advantages of lifting plate and even pieces of steel like this I-beam in shear is you get a lot less tendency to flex. Vertical or shear force lifting can be a great way to lift pieces of steel. You're limited in the amount of flex you can expect. You can start storing things in a vertical rack, which can save you a lot of floor space. It's a good thing to do. It's easily doable. You just have to do the math and make sure you're doing it safely.
Go up just enough and we'll slide it in.